This video goes over exception handling in C++. Um, exceptions are runtime errors that occur when some conditions cause the program either to access resources that are not available. For example, a file, the program is trying to read from a file that's not available, or the file has gotten corrupted and the program is unable to read the data. Or it can also occur because of some commands inside the program which are trying to access data that will cause those commands to fail. What do we mean by that? For example, let's say we are trying to do a division operation, and for some reason, the denominator is turning out to be 0. Now, this is mathematically, this has no answer, and when the program tries to execute a division by 0, then that operation electronically is not possible, and therefore it should terminate. It should not service our program anymore. So when the operating system encounters these situations, then it exits, and it typically gives an error message. And in this situation, we say that an exception has occurred, or the program has terminated, or the program has been aborted. Now let's go and take a look at an example. So I have an example here of division by 0, and I'm going to run the program. And you see, the program has exited, and it has exited with a very, very large number. This is an indication that an error has occurred. Now, some IDEs will exit with this number, which kind of gives us a signal, but other IDEs will give an error message, a more complete error message, which indicates that they have thrown an error. But all said and done, this kind of division by 0 gives us a number, and the program does not continue any further. Now, there are times when we may like to have some more control over how to manage this error checking. And so rather than leave it to the operating system, who will exit the program and may or may not give us an error message that we can understand, oftentimes those error messages are so cryptic, we do not know what is that condition that caused the error. So usually, programming languages offer the facility for the programmer to build in error checks, and for the programmer to check conditions and exit from the program gracefully and give error messages that are meaningful to the programmer. This is also helpful because there may be times when you may not want your program to exit ungracefully or exit unexpectedly and have that exit taken care of by the operating system, because there may be some housekeeping tasks that we may need to do. For example, we are working on a file remotely, and we have access to that file, and we have written some information to a server. We may want to give up access of that file. We may want to inform the server that we are exiting so that other programs can access that file. That's one. The second thing that we also may want is we might like to have that control and decide for ourselves whether we want to exit the program or the error is just not serious enough, and we may just want to give a warning to the programmer and proceed and continue with the execution of the program. So in both these cases, it would be good for the programmer to have control. And so the question is how to do that. The programmer can exercise control by using an exception handling feature like throw. So let's go back to our program and see how we can do throw. I'm going to comment this, and here I'm going to ask the user to enter a number. And I'm going to say if for some reason the input is equal to 13, I'm going to throw an exception, but I'm also going to give a message saying this is an unlucky number. So at this point, execution of the program, if the input number is 13, should terminate and the program should exit. So I would like to run this. And I enter the number 13, and I see that here it says terminate called after an instance of. Now this does not have, we did throw an exception, we did pass a string, but we're not seeing that string here. We're just seeing that it has terminated. And we also see that once the program jumps out of, once we jump out of the program at this point at line number 16, then nothing else is going to get executed because we've exited the program and we're out. So in order for us to get a more meaningful message, what I could do here is I could put this inside. Let's go back to this and say, so that's the first thing. So you see a decision can be made, but it will exit, right? And the program does not continue. So what is the second way? The second way is to use a try-catch block. When we use a try-catch block, we test our condition inside a try block, which just consists of a block of statements. And if the error condition is reached as we are testing or as we're executing the try set of statements, then control jumps to a catch block, which catches the exception and then will process that error and output that error for us so that it will give us more meaningful information outside the program as opposed to all of this stuff. So here I'm going to do the checking here. And I would like, ignore the other catches. For now, we'll talk about that a little later. I'm going to say catch standard string and error. So this message that was thrown here, this string that was thrown here, because it got put inside a try, it's going to get caught here, and I can simply print that out and print the error message and print \n. Now, we will talk about, as you can see, I've built in one catch to receive the error message, but there are other catches as well, but we'll talk about them later. What would happen is after this, I would like the program to say, it won't let me do that unless I comment out. So what I'd like to do is at the end of this catch statement, it will execute this, and I would like control to pass after this statement is printed out, the error is printed out, and I would like to say end of program, and that will be the last thing that I do. So I enter a number, I enter the number 13, and as you can see here, I'm going to change this and run this one more time. I say 13, enter a number 13, and say this is an unlucky number. So it has actually printed out, instead of all the stuff that was happening before, it just prints this is an unlucky number. It has thrown this message, which was caught by the catch statement, it has printed the error, and then it has come to the end of the program and said end of the program. I can also choose to exit. If I find this is a serious error, I can exit out of the program, in which case it will execute this write statement, but it will not come to the end of the program. So here we go. So I enter the number 13, and it just says this is an unlucky number. It did not come here because I chose to exit at this point. So in the try statement, I checked for 13, I threw a message, and I caught that message here in the catch statement because an exception was thrown. I've printed the error. After executing the catch, control passes to the end of this, right? Now here, we could also, if we wanted to know which number, we could also throw an integer instead of a string, or we could throw both. So here is an example of, you can take in an input from the user. If it is less than 0, we can say this is a negative number and throw a negative number exception. And if it is greater than 0, we would like to know what number that is and throw an X. So let's go back and change the program here. And what I'm going to do is I'm going to move this out, or I can, in fact, remove this whole thing. Here what I would do is, if this number is less than 0, I'm going to say else if number is input is greater than 1000, then just throw that number, throw 1000, throw input. So you see here I'm throwing a string. If input is less than 0, throw negative number exception, right? So I'm throwing a string here, but if the number is greater than 1000, then I'd like to know what is that number. So there is only one catch statement here, and it matches this condition where you're throwing a string. I do not have a matching condition for a catch statement to catch an integer. So I can absolutely do that, build another catch and say catch an integer. Let's call this E. And here I can say standard out, cout. This is this number is too large. And then here I can just print that number E, right? So now let's try to run this program. First time, let's try with negative 1. And then here it says negative number exception. This was thrown. It got caught here. And then because after this, it does not, even though this catch statement is under it, it doesn't mean that it's going to get executed. This is the appropriate catch for that integer. So what's going to happen is this catch statement is going to get executed. It's going to jump over the second catch, come to the end of the program and execute that, right? And then here, let me run the program for the negative number, for the larger number, and let's give 2000. And here you say, it says this number is too large, end of program. So it came through the else, through the exception, didn't get caught here because it's not a string, got caught here because you threw an integer, and therefore it printed this. So now what I'd like to do is I'd like to look at the last condition. The point that we'd like to pursue here is that at a given time, we're either able to throw either a number or we're able to throw a string. We're not able to send a complex message. And if we'd like to do that, then what we'd need to do is we'd need to throw a class object, which has an integer, and then we can use that information to print a message and that integer, right? So here, as you can see, I've got a class called positive number, and I can absolutely throw an exception as an object. How to do that? Let's come here, and what I'd like to do here is I'm going to comment this stuff here and say, let the user give some input. Go ahead and check that input. So control is going to jump to this check number. And if that number is greater than a certain upper limit, and we have set that upper limit to be equal to 100 here, right? If that is greater than 100, then throw positive number. Now, positive number is a class. We are creating an object and we are passing that information into that object itself, because we know that objects can hold a lot of information. So let's go down this path. But in order for this exception to get caught, we need to have a matching catch. And what I'm going to do is I'm going to introduce this catch statement, and put this at the bottom, which actually catches an object. So now what I'm going to do here is let's try to run this. And I enter the number 200, and it exits by saying positive number out of range and end the probe. Where did this message come from? This came from this catch statement, which catches an object, an error object, right? When input number exceeds positive limit, right? And then here, now the question, can we have multiple classes? For sure, we can have multiple classes. I've built another class which that has that can catch a negative number. Now the question is, can we have inheritance in an and use inheritance in an exception conditions? Yes, we can. So what I have done here is I've created a base class called bad number, and negative number inherits from bad number. Now the advantage of doing that is that we can create generic exceptions, let's say file error exception, and then we can have file open error exception, file is corrupted error exception, or we can say insufficient data exception, file is locked condition, file is readable or is not readable or not writable. There are multiple conditions that just arise, can be that are derived conditions or derived classes from a file error exception. And we can absolutely here, this is the example of, you can have a bad number and negative number can inherit from bad number. And as you can see, the constructor for negative number, it actually pulls the bad number constructor and the input number is given there. How can we call in the main program? You see, I've created a catch statement that takes in the base class, and as you know, wherever a base class is expected, a derived class can be passed. So here what I'm doing in my check number method is, if the number is greater than upper limit, throw a positive number object error object, and if it's less than the lower limit, throw the negative number. When this negative number object gets thrown, then it's going to get caught by bad number here, because bad number is the base class. And the lower limit is -100. So let's check this program. It says enter a number here. I'm going to come here. We should just make this program terminate. Let's give the number -200. And as you can see, it says negative number out of range, -200, end of program, which means this bad number exception was caught. One thing for us to note is that this method is defined here, which is throwing the exception, but it's called inside the catch. As long as the calling function is throwing the exception, then it's going to be caught by the catch statement that accompanies the try. There are other complicated situations where you can nest exception calls if there is no corresponding. If you have nested function calls, then if the innermost try does not have a catch, then the exception gets kicked up one level of the function call, and then it keeps going all the way till, if it doesn't find the corresponding catch, it will go all the way to the main program, and then it will forcefully exit from there. So all of these, so I just would like to share that the link to the replit that I've been using has been included in the last slide, so you can absolutely view the demo as well.